Hello my lovely juniors, welcome back. In the part 4 we are checking about the types of DC motors and its applications in the industry. Okay. Okay, so if you see here, we have the electric motors. Already we discussed about this one, right? Synchronous, what is meant by synchronous, single phase, everything. So today we will see this one, okay, this part. So the under the direct current motors, we have the brushless and brushed, okay. So brushless already explained you. So we don't need the direct current, like brushes, we don't need to induce the EMF, okay. And we have the brushed one, we have series, shunt, component, permanent one. So first we will check the DC motors. So this is the architecture, and then in the brushless motor we have the three things. One is the inner rotor, outer rotor and disc rotor. We will see each one of them. So this is the how the brush look like in a motor. So as I told you, so if it is a motor, so this is the rotor, here it will be a coil, and then it is called as a commutator. Here means it will be which will be around the rotor, and then we have one stator. So this is the stationary, this is the south pole and this is the north pole, and this is the brush, okay. So it will be around here, which is inducing the EMF around the rotor. And then we will see the what is meant by the brushless motor. The brushless electric DC motor, also known as the electronically commutated motor or synchronous DC motor, is a synchronous motor using a direct current. So otherwise you can directly write it like this. It is an synchronous motor using a direct current electric power supply, okay. And then there is a brushless DC motor, okay. In this one we have the inner rotor type motor. So in this one, the inner rotor type that has the magnetic inside acting as the rotor, while the winding temperature is arranged outside the stator, okay. This one, correct. So this is the rotor and this is the stator. What they are telling, that has the magnetic inside acting as the rotor, while the winding is arranged outside as the stator. So here winding will be there. So inside whatever the thing that will be there, that will be acting as the magnetic inside the rotor. So that is the inner rotor, okay. Same if you check about the outer, it will be in reverse. So these are the features of, like small movement of inertia will be there, and the ability to downsize the main unit, and high heat dissipation efficiency will be there since the windings are outside. So what is a rotor type? So it will be exactly reverse. See, this type of motor has coils on the inside and magnets on the outside. Before what were having, it was the reverse, right? So it called as the inner type, the magnetic inside, this is the magnetic outside, and these magnets serves as a rotor. So inside it will be now here outside magnetic, and inside we have the winding. So this is called as the outer rotor type. So it's a great moment of inertia, and it will be having the also the downsized one, and it will be having the low heat dissipation, okay. And then disc rotor type. Disc rotors are the permanent magnetic stepping motors that exhibit performance comparable to that type of hybrid motors. Rotors inside disc motors are thin, typically less than 1 mm disc. 1 mm disc. So unlikely the cylindrical rotors in hybrids and conventional permanent magnetic motors. So main here will be like the stepping motors that will be exhibit the performance comparable to that of hybrid motors, means normal motors which we have discussed before, okay. And in the brush we have series, shunt, component, permanent. So as I told you before, the brushed motor is an internally commutated electric motors are designed to form a current power source and utilizing an electrical brush for the contact. So if we are, so this is the rotor, we'll use an electrical brush like this, which will use to run this rotor. It will use the EMF here. Okay, that is the brushed motor. So in the brushless, it will be not there. That's why they are using the magnet inside and sometimes outside, or else on the disc. Okay, and then shunt motors. So it is also same. This is the permanent magnetic motor. We will have the permanent magnets inside to run the motor. As I told you before, I am really sorry. Like much detail I cannot tell, but as this is the basic notes that you can write if they are asking in exam, but anything related to the instrumentation, automation, so I will explain you very clearly. So these are the application of DC motors, and in the next chapter we will see types of stepper motors and its applications in the industry.